So, hello. My name is Jaanus, and I will be talking about Corpus distillation, and if I pronounce it incorrectly, sorry, and fuzzing. So, let's get going. First of all, a little bit about me. My name is, like I already said, Jaanus Kääp. I'm coming from Estonia. I work in a company called Clarified Security. Maybe some of you have heard about this. Our main job is vulnerability testing, research on these subjects, trainings, and we also help to help a lot of quite large cyber defense exercises. And this guy there, raise your hand, Hilliand. Or beers, yeah. This guy, if you are interested in NATO level exercises that being held in Estonia, ask this guy, he can talk you, oh, thank you very much. A lot about this. My background was in development. I was in both web and native applications developer, and I don't put here my certificates, but I have found multiple bugs and vulnerabilities in both web and native application from Facebook, Adobe, Google, etc. So, why I will talk about fuzzing and Corpus distillation. This is the result of my last year, like half a year of research and fuzzing. These are all either already published vulnerabilities around 0 days, or vulnerabilities and 0 days that are being published in next couple of months. Those all were bought by ZDI from me, and I put up only those that I actually bought. So this method is quite good. It doesn't need much knowledge, actually. Just I wrote program, let it run, and it made me money. So yeah. I will describe what I did exactly. What I will talk about is, first of all, out of curiosity, out of here, how many of you know what fuzzing is? Really cool. How many of you have done fuzzing? Really cool. How many of you have done fuzzing and found something? Awesome. How many of you know what corpus distillation means? Great. I was asking what corpus distillation means, the word on the second line. Okay, really good. Maybe I can help you then. Then I described a little bit how I fuzz, and also I introduced the tools that I developed that I used to find all those zeros and make some money. And they all will be public, actually already are public. You can download from GitHub. And if there's any time, I'll make a small demo. So, a little bit about fuzzing, for people who don't know what it means. It is pretty much, you can understand it as automated vulnerability or bug finding tool. What you do is your tool will generate some inputs. It doesn't matter, is it network traffic, some files or something like that. Then it runs those inputs against the target that you are fuzzing. It detects crashes or special conditions or exceptions or signals. And then it repeats and repeats and repeats endlessly. So, in this kind of situation, what are you detecting? First of all, you detect crashes. For example, if your fuzzing target crashes, this is something you might be interested in. In all situations, it doesn't crash in several exception cases, and thanks to that, you might try to catch exceptions that's going on, or if you're fuzzing web target, you might be catching for crashing stuff, or error messages, or some special input or output if you're, for example, fuzzing for cross-site scripting, which is really stupid, I think. So overall, detection is really target dependent. If you're targeting some, for example, some file reader, then you're detecting for memory corruptions mainly. If you're targeting some services, then also the crashing itself might be beneficial, and so on. A little bit about how you generate the input, and this comes really hardly in corpus distillation. You have two different approaches of generating the initial input. You have dumb fuzzing, which I break up to do different dumb fuzzing styles, really stupid random fuzzing and mutation based, and you have smart fuzzing. So, A little bit about each of them. Total stupid randomness is just you generate total garbage with the random or whatever, and you put it to file or put it to network traffic and hope that something happens. It is really easy to create, but it almost never works because almost all of the web type, file types and file protocols and network protocols have some strict signatures, and if you don't catch them, well, parsing doesn't go even farther. So it's pretty useless. Mutation-based. Mutation-based means pretty much that you take a valid input, and from this point on, I'm focusing on file parsers, like PDF readers, Word readers, or something like that. You take, for example, one file that the reader correctly opens, and then you make tiny little changes inside of that, and try that against the targeted machine, targeted application. And these little changes might be different things, bit flipping, adding some special values, adding long strings, etc., etc. Pros is that it is still easy to create. Like, you don't have to know anything about the protocol. You get better coverage compared to the previous one, but the downside of this is since you are fuzzing something without knowing actual content of it, you don't know how much of the functionality you cover. And the coverage of the functionality depends highly on the initial file that you are mutating. And there's smart fuzzing, that is most commonly called, or generation-based, which means pretty much that you implement entire protocol. You, in case of, for example, PDF file, you have to know exactly how PDF file is created, how it's parsed. So you create valid PDF files that some values are a little bit messed up. But to do that, for example, with PDF, you have to code a lot because you actually have to implement every PDF functionality, every logic that is inside the PDF. So pros is that it is best code coverage if well implemented. You have better control of what are you fuzzing. But the cons are that it's really time consuming to implement. And if you are targeting something that is not open source or open protocol, then you have to do a lot of reverse engineering to figure out how the file or network traffic is generated. So, what I did. First of all, I'm lazy. I don't want to spend months and months implementing some file type or something like that. I still wanted to find vulnerabilities, and I had a couple of computers laying around that I could use for just computing power. So, dumb fuzzing it was. But like I said, in case of dumb fuzzing and mutation-based fuzzing, the code coverage of the target is highly dependent how good files you have at the really beginning. So how you can improve the initial files that you're going to fuzz. And like I said already, I took PDF files because PDF files have a lot of different readers, so really high and large attack surface. And what I wanted to get is the initial set of PDF files that has as high, as large functionality coverage as possible. For me, PDF type was unknown protocol. I didn't know exactly how it is generated, and I didn't want to write the tool to generate this. But in the same time, it is really, really common file type, so you can find a lot of PDFs in internet. And you have also a lot of readers. So, thanks to that, we got to Corpus distillation, and I'll take a sip. What do you need? Pretty much what you need for first is huge number of initial files, a lot of PDF files. You need some application to read them, and you need time and computing power to actually go through all of them. Then you calculate code coverage on each of those files. And then you analyze the resulting code coverage of all of those analyses, and you minimize the set. So the final set contains all the code coverage as the initial set. The final set contains same coverage. So, quick example. Let's say we have 5 files. First of those covers A, B, and F functionality. Second one contains A, C, D, E, and so on, so on. You could start fuzzing them all, but you will be re-fuzzing A in all of the inputs, and many others are also doubled. So actually you can get exactly the same code coverage with only first and second input file. So my goal in this kind of situation is not to get 5 files at the start, but like 500,000 files, and minimize the set that your final set contains same functionality coverage as those 500,000 files. How do you do it? How to calculate code coverage? Well, with open source tools, it's quite easy. You have special flags that you can use in compiling, and that makes a compiler to add certain instructions inside the code, so you can calculate code coverage quite effectively. But what if it's a closed source? You have a couple of options. First option, the easiest one, is just trace the entire code. Pretty much do write your own debugger and trace the entire code. And that is dead slow, because if I, just out of curiosity, tried it, and I used this laptop, it had VM in it, Windows VM, and I tried to trace through calculator.exe, calc.exe file, it took 3.5 minutes to get the picture. So this is, in real life, not usable. There are some libraries, Pin, for example, from Intel, and DynamoRio, that can do somewhat attached to the running process or executable and do some instruction analysis and this kind of stuff on them. And they are very good tools, but they're kind of slow for this because they are multi-tools. You can use them for a lot of things. So I decided to write my own tool for that. So what do you need if you're writing your own tool? First of all, you don't need to trace every single assembly instruction or computer instruction inside executable and DLLs. You actually need basic blocks. Basic block is a small part of the code that has no branching. So it's just some snippet of assembly code that has no branching, that is always, if it starts here, it is running through entire of this code, unless you have a segment fault or something like that, but this is a different situation. So first idea was to put breakpoint at the start of each basic block inside the executable. And then just write down all the breakpoints that the code covers. So I used IDA Pro and IDA Python and recorded a relative virtual address, RVA, from base address for all the basic blocks. So my first run was with Foxit software. It had 611,000 breakpoints or basic blocks. I set up my tool in a way that it stops working when it stops analyzing if for 8 seconds no new breakpoint is catched or happening. So it took 180 seconds at the start of execution to put the breakpoints inside the process, because there was a lot of breakpoints. And the actual execution took only 30 seconds. So in total, it took 210 seconds to analyze one PDF file. And I had 366,000. Well, that would take quite a long time to analyze them all, so I was looking for ways to speed it up. First of all, the most time that was spent setting breakpoints, so just putting byte values inside the existing process. But what is the breakpoint? Breakpoint is assembly interrupt tree, which is actually in opcode, it is XCC. So why not to put those breakpoints inside the existing executable and DLL files? Because they're just assembly code, so you can just put it into executable and DLL files. So again, I went back to IDA Pro, and now I recorded RVA from the base address, so where the locations will be inside the memory. Then RVA or offset in the file, because they're not always same. If you map executable or DLL from file to the memory, they are not always same, because there's a lot of other stuff in file that can mess it up. And the original value of this byte that was overwritten in executable or DLL. So new process of analyzing was to first analyze it with IDA, then generate files of basic blocks, where basic block is in the disk, in the memory, and what is the actual value of the byte. Then actually modify the executable and DLL files, and during the execution, catch all the breakpoints. If breakpoint is inside basic block list, then record this location, replace breakpoint CC with original value, and move instruction pointer back by 1. So, result, exactly the same setup, and now everything worked. It took a little bit of time to get it working, but it worked. And now we had 7 times faster. Now, additional optimization. Since a lot of those basic blocks that will be covered are covered always in every execution, like setting up the program and everything on and on, so you actually don't need this information. So what I did, I was downloaded 100 files, took the file that had best code coverage, put that aside into the final set, and removed all the basic blocks that was covered by this one file. With this, I got it down to less than 600,000 breakpoints. I don't remember exactly how many. Same setup in how many seconds to wait for new breakpoint, and the execution reduced to 13 seconds by average. In many cases, the execution was 8 seconds because no new breakpoints were covered compared to the initial, the analyzed one. So, what was the benefit? I had 366,000 PDF files. At the end of the analysis, I had 726 files that covered the same functionality as 366,000 files. So I was covering same functionality when I was fuzzing than I would have when I was fuzzing 366,000, but I was actually fuzzing only 726. Total code coverage was 21.8%. It seems small, but actually it's not, because it was default installation. So there's a lot of like clicking in options, clicking mouse buttons, all this kind of situation was not counted for. Only the base functionality of parsing. So in that view, I don't know, is 21.8 good or not? And it took about 2 weeks for one. I used my home gaming PC to calculate this, and it was running, I think, 4 or 5 VMs. So it took 2 weeks. It comes to up how big or how large initial set you need to get best code coverage with this kind of tool. For me, this graph pretty much shows that how many new files into the final set I got per 1,000 files analyzed. So at the start, I got 5.5 about, and it reduced. So based on that graph, if the ending of it is quite linear, then I probably would have needed 500,000 files to get pretty much all the code coverage as I needed. But I am really beginner in this level, because Google did similar thing with Flash, and they downloaded 20 terabytes of Flash files and then used 2,000 CPUs to do this kind of thing. My CPU has 4 cores, so it's not really comparable. And yeah, and then use those same 2,000 cores to do actual fuzzing for 3 weeks, and found like 80 or something like this 0 days. Not 0 days, but memory corruptions at least. So, but how do you get 366,000 files, PDF files? The easiest solution is you just type file type PDF, and Google says, it's in Estonian, sorry, that he has approximately 18 million PDF files, which is really cool until you reach to page 11, and it says, no, I don't give you more. You have 500, and I don't give you more. And there was additional problems. A lot of the PDF files was actually just some other type of file that had PDF extension, HTML files or something like that, that just ended with .pdf. And also, Google really doesn't like you doing this kind of thing, because if you start downloading and doing automatically requests to them, they will kind of block you quite fast. So that was also a problem. So my solution, I went really easy. I filed a PDF AAA, filed a PDF AAB, AAC, AAD, and so on, so on, so on. My script did it like this. And because there's so many PDF files, then most of these 3-letter things actually gave a result. Actually, I started with AA, like 2 letters. So, and in demo also, I have a lot of anonymous alcoholics documents, thanks to that, which It's not because of that, it just happened. Also, how to distinguish between real PDF files and just like HTML files that have PDF extension. There's magic value at the really start of a PDF file, %PDF. So you pretty much get the new address, try it. Is first 4 byte %PDF? If yes, download. Otherwise, skip that. And DDoS protection, it's all about timing. It's pretty much like you ask for a page, then download all the files that you get in that page, and then just wait a little bit. Then ask the second page and wait again. So, and it took some time to get the timing right, that the DDoS protection didn't activate it. But currently at my home, I have one computer that has been downloading doc files for last 2 weeks constantly and has never been blocked. So it was surprisingly easy. I thought that their DDoS protection is more creative, let's say. So, how we fast? I mutated input files, run executable with my own debugging tool, and wait for crash or exceptions. And then I did some reporting and primary filtering on all the findings. Well, what mutations, all those things that I've showed you, were found by simple bit flipping. I didn't do some interesting changes in the files. I just randomly flipped like 0.01% of bits inside the PDF file. That nothing else was needed. This was enough. But you also can add long strings for overflows or special values and that kind of shit. How to detect? Well, first of all, you want to detect crashes. But the fact that the application crashes doesn't tell you much. So we actually want to catch exceptions in Windows case and signals in Linux world. So you're interested in Windows, for example, access violation exceptions, depth exceptions, and all this kind of stuff. And if you're doing this kind of fuzzing, please turn on full page heap. You do it with Microsoft own tool, gflags, turn full page heap on. With that, you will find heap overflows and exact equations where they happen. I will not describe here what full page heap actually means and does. I can explain it later in QA, but you're gonna need it. You're really gonna need it. What to also keep in mind, if you keep your ASLR enabled, then all your results and location where the crash happens are always in different memory locations. So you have to keep ASLR calculations in mind. You will also have a lot of random crashes because, I don't know, stars were aligned and you just happen to have a crash. And the same file that caused the crash once might not cause it again for totally random reasons. And thanks to that, I had to implement a way that when my application detected a crash, it tried it again. Like, it didn't trust it that if it crashed once, that it will crash again. Also, the more instances, the better. If you can create 30 instances, then create it, because the more instances you have running, the more fuzzing that you can do. I think in Adobe Reader, my record was having 42 same time instances running. It wasn't really stable, but I got it to run. And also, you kind of have to do filtering of the results automatically. And why you want to do it? Because in some situations, you will get hundreds or even thousands of crashes per day or week, and you don't want to go through them one by one. So my simple filtering was the crash happening near null or not near null? Or if I repeated the initial input again and again to see does it crashes again, then both. But you want to know, is it near null or not near null? Then you want to know what type of exception it is. Is it access violation? Is it DEP or something else? Then, of course, the location of the exception, the different between different crashes. And if there's a lot of crashes, then you kind of want to have some kind of stack trace signature also. So, and also, along with the input file that generated the crash, you also want to know the code in the crash location, so you can fastly analyze, is it interesting for me or is it not? The stack trace and register values. You just, thanks to that, you know what to keep analyzing. And when you finally find some vulnerabilities with these methods or similar methods, then there's a lot of things to do. You can directly inform the vendor. For example, with web application vulnerabilities, I have done so. Directly inform vendor. Some of the vendors even pay you. Like, actually, the coolest is Facebook. Facebook will send you a credit card that says Bug Hunter as its name to you. It's really awkward when somebody asks document, but otherwise it's totally usable. You can sell vulnerabilities to CDI. This is a kind of ethical way because they don't make it public before the vendor has fixed them. Of course, you can do full disclosure and make it public, but this is kind of here and there. And of course, you can make even more money by writing exploits and selling them for example, Zerodium. But in this case, you have real large and high ethical problems. And of course, you might want to write exploits for yourself or for your company, not in a goal of stealing something, but you can actually do, for example, pen testing against companies that pay you. That's legal. So you can create actual working exploit for yourself and not do actual crime. But yeah, these are the options. And like I already described, I have either informed vendor directly or sold these vulnerabilities to CDI. So, a little bit about my tools. I have two tools. First is Fuzzer, called Vanapagan. It can do fuzzing on Windows, Linux, and on Android over ADB. And the other tool that is actually more important because there's a lot better fuzzers than that one out there is Kavalants, which I use to do code coverage. To be said in front that both of them have no documentation. The first one has a lot of examples, but no documentation. And currently both are developed as my own needs dictate. Now, if anyone here really loves writing documentation, he can let me know, and I will find you some documentation to write about those. And also Kavalants, the coverage tool, needs IDA Pro for initial analysis, but not for later on coverage execution. So you can ask some friend of yours who have IDA Pro to do the initial analysis of DLL and executable files. And after that, you can do it on your own without needing even IDA Pro. So I will just a little bit demonstrate how much I can in here. Like, I'm sorry, all of the stuff here is not registered because I just created this VM from the demonstration. I don't steal that much software, so this doesn't count. Okay. Up. So what is going on here is that I have, let's take for example, Microsoft Word. And let's take this example. This just show how fast it runs while still recording all the code basic blocks that is being covered. Sorry. Now, it doesn't cover all the basic blocks in Microsoft Word. I did this previous analysis that that I analyzed 100 files and removed basic blocks from the most common file or the largest file. But this is the speed that it runs, and all of those, the code coverage tool and the fuzzing tool, are as libraries. You can use them in Python as you want yourself. They are not separate tools, but libraries. So this makes using them quite easy, but you just have to write a couple of lines Python. But in this case, I will try to run. Hopefully it doesn't crash. So it reads information about breakpoints, reads in all the locations of the malware, and it started. Now, remember the suite. Now if I close this, it will open the next one. Okay, it closed it because 8 seconds passed without opening, covering new basic blocks. But if you look the result file, this will now contain information about all the basic blocks covered inside, and there's quite a lot of it. I think it's around 10,000. So if we now compare it with some other tools, let's compare it to the fastest tool that is alternatively. Let's put it like this. This is timer over IO that is used in similar situations, and in a version that I will run, it doesn't do any code coverage, it just opens the executable. So no additional coverage is recorded or anything, and it's still slower than this version. And that is the speed of Dynamo Rio. So you can see that this kind of way, how you only record breakpoints that you are interested in, is much faster than using tools that are currently used for this same method. So in this case, my tool is actually even faster, which is nice. Going on, actually I'm quite already finishing in this topic, but I have a couple of extra requests. If anyone gets any use out of my program and actually finds something with this, please let me know. You don't have to say where you found it, how you found it, where did you sell it, or what did you do with it. Just let me know. It's nice to know. And for me, last year, everything that I found, I donated 15% to charity. Please donate at least 10% also. And if with no other reason, then Fuzzing needs luck. Donations increase karma, and karma should increase luck. It doesn't, but it should. And I think we should behave based on that. So, Q&As later on somewhere, probably. So, yeah, I'm done.
Do you mind sharing the code?
Sorry?
Do you mind sharing the code? Code.
Oh. Sorry, I thought that I put it there. Code is there. It's publicly available. We can leave it up for a couple of minutes if anyone is interested. Or if anyone wants to ask any questions based on that, then you can. And actually, even easier, you can send me email. Either here, or you find my email also in Clarified Security webpage.
Thanks, man. Right, so if you want to automate your zero-day findings, this is the guy.